Guten Morgen, meine Damen und Herren. Es freut mich, Sie alle hier begrüßen zu dürfen bei unserem Webinar zum Thema Halbleiter, Smart Factory, Robotics und Sensoren. Japan ist das große Thema heute. Ich bin der stellvertretende Wirtschaftsdelegierte hier im Außenwirtschaftscenter Tokio. Ich sehe, wir bekommen noch Besuch von ein paar Teilnehmern. Es ist eine gute Gruppe heute, fast 30 Personen, die sich angemeldet haben. Dieses Webinar wird von mir gemeinsam mit unserem Key Account Manager Andy Kondo gemacht. Andy Kondo ist bei uns seit etwas mehr als oder fast 2 Jahren als Key Account Manager im Bereich Smart Factory, Robotics und Semiconductor tätig. Wer letztes Jahr dabei war im Webinar oder sogar vielleicht bei uns hier in Japan bei der Wirtschaftsmission zur Semicon letztes Jahr, der kennt ihn auch persönlich. Wird dann auch gleich online kommen. So, as today's webinar is in English, I want to switch to English. Again, welcome to everyone who joined our webinar today. It's all about smart factory, semiconductor industry, robotics, and Sensorik in Japan. And it's indeed a very, very interesting topic. And Japan is a very timely market for that. We've seen a lot of things happening here. We'll go into details soon. First of all, I want to say again, hello. Also, we have a few participants today from Japan, from Austrian subsidiaries here in Japan. So Advantage Austria, Außenwirtschaft Austria welcomes you here. As everyone knows, we are your extended office here in Japan. This is just an image picture that I took out purely because of interest. It's the high-profile project in Japan these days. We're talking about the Rapidus plant in Hokkaido in Chitose. Is this why did I pick it up? It's not so much about this particular one company that's a venture of 8 big Japanese companies, but it also shows a bit like the determination of Japan and the Japanese industry to catch up in this area here. These are the pictures from this winter. So construction went on throughout the winter. The second picture is from just May, most recently. You can see the building going up already, and it's supposed to come fully online by 2030. But first, prototype production and so on will already start in 2026, 2027. But maybe taking a step back here, most of you that are a little bit familiar with the Japanese market or the international semiconductor market, of course, know that Japan commanded a huge share, maybe some 50% of the market share in semiconductor sales in the 1980s. From there on, it went steadily down, particularly in the chip making, not so much in some additional key industries. And then, as in Europe, 2020, 2021, there was the big wake-up call. There was the chip crunch. And additionally, that's different from Europe, there was a study here done by the Japanese Ministry for Economy, METI, as we usually call them. And they basically showed that if the trend continues as it was in 2020, there will be no more chip production in Japan by 2030. So that, of course, rang all kinds of alarm bells. Among others, also the big Japanese automotive industry was really shocked, particularly as there was the chip crunch at the same time. So supply chain crisis, no more on chip production, and fire on the roof, so to say, for Toyota and the others. That, in turn, really moved the Japanese government very quickly. We saw a huge shift in the strategy. First, there was a semiconductor strategy before 2020, but it was a kind of like maintaining by low-level subsidies as sort of a state of play, as always, too little for really prospering, too much for bankrupting. So what happened next is that in this new strategy, 2021, METI did a strategy within 3 months. They came up with a very strong strategy. They want to focus particularly on building up a national production capacity again, very much focused on advanced memory capacity, next generation of chips, advanced packaging, while maintaining, and that's really important, Japan's traditional strengths in many of the, let's say, supplying areas. So Japan still has some 45% in material supplies to the semiconductor industry, some 33% in chemicals, gases, 29% in integrated design manufacturing, and also some roughly 25% in equipment. How do they do it? You all probably saw the headlines. Japan government is handing out unheard of subsidies to companies. The first ones were, of course, the big names, TSMC. They got with the number 1 and 2 plant, maybe some more than 7 billion euro subsidies. Rapidus, we don't actually know how much they get in terms of subsidies, tax cuts, and so on. We know that the whole build up for Rapidus is probably going to cost some 28, 29 billion euro until 2030s. And they will, of course, dive deeper into these topics. I just wanted to provide the framework. Another important framework that we have here is the Japan-EU axis, so to say. Japan and the EU were a little bit at the same area of the supply chain crunch. There is now a semiconductor part of the EU-Japan digital partnership. We've seen recent movement. So there is Department General of the EU, Connect, and METI, the Japanese Industry and Economy Ministry, have signed an administrative agreement on how to exchange information on subsidies. So you want to avoid a race to the bottom by providing, getting in competition for too much subsidies and being unclear. What we then see is some research partnership efforts. We see that there are attempts, mostly by expert workshops, to actually find out, to map out where are possible mutual benefit areas. And then again, of course, the whole issue of economic security, that's of course a supply chain crisis as it once was in 2020, 2021, but also of course the geopolitical axis with China, US, China, Taiwan, and similar topics. So these are all very, very hot topics now. So that having said, I want to pass on the screen actually to Andy, who is of course our expert and can provide much more detail. Andy, would you come online?
Good, thank you. Good morning, everyone. This is Andy Kondo. I'm gonna talk about the Japanese market today. Let me share my screen. So let's start today. Once again, this is Andy Kondo from Advantage Austria, Tokyo. Thank you for joining us this morning. Yeah, so many people already online. Yeah, thank you very much. So I'm going to talk about the semiconductor, smart factory, bit of sensor and robotics things, mainly smart manufacturing topics. First of all, we start from semiconductor topic. I want to refresh your memory of our country, Japan. We are quite long island country from north to south. Then up north, we have Hokkaido Island, big island, which is almost similar size as Austria. I just put the size of Austria here. Maybe you can imagine how big, small, our country is. Then I'm from Yokohama. Actually, I'm in my office in Yokohama. This is the really research and development complex city. So many big companies. They have research and development buildings here. And also we have, I know the Silicon Alps organization community is in Austria. We have quite similar things. Japanese Alps, Highland Technology Valley, around here. The Japan is almost like a 70-80% is the mountain area. Then within the mountain area, some of the middle size of the city, they have sophisticated, really fine machining technologies. And historically, they have, watch assembly industry. Actually, Seiko is coming from this area. Then such a, Switzerland, like such a highly sophisticated manufacturing cluster is locating in the mountain area. You could see the Nidec, like a small motor, one of the biggest motor company in Japan, and also Minebea is the big name with the bearings, such a machining. Then some of the semiconductor companies are also located here. Then Hiroshima, this actually around this area, water is quite quiet. Then big harbor, port city is alongside of the harbor here, sea line. Then one of the biggest ports is in Hiroshima, and also the other Okayama or this industry city. Then they are the hub of the importing oils from overseas. Then for that, chemical, advanced material, those industries are really growing up in here. You could see that Mitsui Chemicals, Asahi Kasei, this is also one of the biggest chemical companies, these things. Then these days, semiconductor companies are also coming up in here, like a Mitsubishi, Micron. Yeah, I'm going to talk about the Micron later. Then today's big topic is in the semiconductor, this island, Kyushu Silicon Island. This island, Kyushu, has been really, silicon, center of the silicon in the 80s. Let's say before Silicon Valley is coming up. Silicon means this island, Silicon Island, Kyushu. You could see so many big names here. Maybe I can visit this Silicon Island later. Arnold mentioned lots of subsidies are coming to the semiconductor industry. This is the rough overview how big money injected into the semiconductor industry in Japan, all over Japan. Big projects, yeah, Rapidus, Arnold mentioned in up north, and also south, Silicon Island, Kyushu. We have two projects, big projects. One is, of course, TSMC. The other is in Toshiba, Rome, in Miyazaki. This is the power semiconductor project for the automotive industry. And Micron, Hiroshima, this area, this is also a quite big project ongoing. American, DRAM and memory company, Micron, actually they are building up the really sophisticated process in here. And also in the DRAM company, Kioxia. Kioxia is formerly known as a Toshiba memory company. They changed the name Kioxia. Then together with the American company, Western Digital, yeah, you may have heard this of Western Digital in your computer. They are joint projects. Two projects are running up in north, and one is near to the Nagoya. And the other Taiwanese project, this is the PSMC, not TSMC. This is in a power semiconductor manufacturing company from Taiwan. This is the actually for the automotive industry, power semiconductor. This project is happening in up north. So used to be silicon semiconductor or Silicon Island, but these days Japanese government put a lot of money all over Japan, different projects. Then the significant ones we visit today is in Rapidus and also TSMC. Okay, let's start. TSMC Kumamoto, Kyushu Silicon Island. You can see the chart on your right-hand side. This is the history of the Silicon Island. Actually, this material information coming from the Kyushu Semiconductor Association. From 70s, Silicon Island started. Mitsubishi or Toshiba, big Japanese companies, established the semiconductor factories in this island. Then semiconductor, at the time, that was the silicon is rice for the industry. We call it really necessary material. We call it rice in Japan. That is why semiconductor was really the rice for the industry. Then 80s, 90s, yes, keep growing up. At this time, Japan as #1 era. Then semiconductor industry, manufacturing, actually Japanese company, Japan was really strong at the time. Then going up and up, then Japanese bubble economy, boom. Then going down a bit, but Windows is coming in. Then personal PC market open up. Yeah, going up. Then peak at the year 2000, then going down. Samsung coming in Korea, Taiwanese companies, they scale up the manufacturing. Of course, Silicon Valley, then domestic manufacturing going outside of Japan, like China or Southeast Asia. Then Kyushu Island is somehow getting quieter. Then like this. But you could see on your left-hand side, so many big names here, like a Kyocera, Rome, Asahi Kasei, Toshiba, Sony. Yes, so many semiconductor manufacturing facilities are here in Kyushu Island. And these are the semiconductor manufacturing site. Then supporting this industry, equipment, materials, gas or chemicals, all those supply chains are also located in here. That is why this island is so-called Silicon Island. Then this Silicon Island is now getting back. Thanks to TSMC, 2022, already 2 years ago, Japanese government made a huge decision, put lots of money to establish new factory, TSMC, in Kyushu, Kumamoto, in here. Yeah, such a big money will be. Actually, this is injected to the this project. Then TSMC is coming, but TSMC Japan will be like a JASM company. Then stakeholders are Sony and Denso. That means TSMC, Sony, Denso, those three companies creating a new manufacturing company called JASM, Japan Advanced Semiconductor Manufacturing. Then location is in the middle of rice field in the Kumamoto, but just next to Sony Semiconductor CMOS image sensor factory. CMOS image sensor is always two-layered technology. One thing is sensor, then the other is computing, how to understand, how to process the captured image. Then Sony is going to create the image sensor. Then TSMC Japan JSM factory will create the computing. Then combine together CMOS module shipping out. This is the grand design of the this setup. Then announced by the TSMC, this factory is not that sophisticated product like a 12, 16 nanometer FinFET process. And also the other stakeholder, Denso, actually they talked about this factory in 2022. That was the to support the automotive semiconductor supply chain to make it more stable. They want to have this manufacturing process 22, 28, conventional process microcontroller for the automotive, then manufacture in here. That is the original plan. Now, yes, factory is ready after 2 years. This is a really surprising thing. Just 2 years, such a huge semiconductor factory are opening up on time. This is a really great thing. Actually, this manufacturing done by a company called Kajima. Kajima is one of the biggest construction company in Japan. They created a special team to support the building up this factory. 365, 24/7, all the time construction is ongoing, special project. Then within 2 years, yes, like this. Then they will, now all the manufacturing equipments are actually bringing to this building, then pilot running. Then by the end of this year, 2024, actually delivery will be started for Sony and Renesas. Renesas is the big name of the semiconductor in the automotive field in Japan. TSMC second factory is already, project is ongoing. First one, yeah, I show the this page, like middle of rice field, new semiconductor factory is popping up. But now this place is really getting like a heart of the Silicon Island. You can see the TSMC JSM first factory here, just next to Sony Semiconductor. Then TSMC's second factory will be open up just next in here. Then Tokyo Electron, they are quite, one of the biggest semiconductor manufacturing equipment company in the world. Actually, they had a R&D office and also a small support center in just next to the Sony Semiconductor manufacturing. But they will also expand the R&D capacity in here. Actually, they secured this ground, then they build the new building of the Research and Development Center to support these activities. And Sony, they will open up new factory in here, this area. Also, factory number 1 and factory number 2. Then this means this area is getting really the center of the Silicon Island. Now we can say Silicon Island is really back. And also other project in Kyushu area is really happening. Yeah, hopefully, Silicon Island will be really busy like 25 years ago. That is the Japanese government really expecting. Then TSMC first factory was, let's say, conventional process, not really sophisticated semiconductors, supplying existing business. But now, second factory is even more sophisticated process are planned, like a 6 nanometer, 7 nanometer process. And also, Toyota is part of this project as well, this TSMC second factory. Then this one will be ready like, within 2 years again. Such a big change. This small town just next to Kumamoto city, middle of the rice field, now really heart of the semiconductor in Japan. So back to the Japanese map, up to north, Rapidus, Chitose, Hokkaido. Rapidus company, established in 2022. This is Toyota, Denso, Sony, NTT. NTT is like Deutsche Telekom, like a big telecom company, and NEC, then SoftBank. Kioxia is the formerly known as a Toshiba Memory, and MUFG is one of the biggest bank group in Japan. Those 8 stakeholders and lots of money from Japanese government, this Rapidus company created. Then what they do, they will achieve 2 nanometer process manufacturing in Japan. Then they selected the location, Hokkaido, Chitose. That factory is the, actually Arnold showed a picture. That's a factory. Then that 2 nanometer process technology is coming from, thanks to our friend in the States, IBM, United States, and also from Europe, Belgium, IMEC. Those 2, our friend from Europe and America, all the technology combined together, make it really happen in Chitose, Hokkaido. That is the Rapidus 2 nanometer project. Ooh, such a beautiful illustration. Actually, this is the factory called IIM1. They call it Innovative Integration for Manufacturing. Then their planning is April 2025. Yeah, less than 1 year. Actually, pilot line will be ready. Then construction, actually groundbreaking ceremony happened in last September. That means, again, 2 years of the project. Then factory building will be ready. Then prototype pilot line starts up running. Such a really challenging project happening in up north in Hokkaido. Yeah, by the way, 99% men in the Japanese semiconductor industry. That is the kind of problem. But yeah, okay, that's the thing. Yeah. So this is a picture. Yeah, you already seen. Then construction again by Kajima. Kajima, they create the TSMC Kumamoto factory building. They are also in charge of the construction. Then Hokkaido is really up north. Actually, Sapporo is the one of the heaviest snow city in the world. But such a place, then again, 365 days, 24/7 construction ongoing. That means they created a big roof. Then under the roof, doing the foundation and construction things, then building up such a factory building. Really, challenging construction process ongoing. Then location is just next to the Chitose airport. The Sapporo is the big city in Hokkaido Island. Over I think 1.5 million people living in there. Yeah, quite a big city. Then international airport just next to it. This site is in here. Why? Why Japanese government put so much money to Rapidus? And why Rapidus challenging to the 2 nanometer process? Because this is the reason. Sorry, Japanese presentation materials from the METI, but this material was only available in Japanese. That is why I just put in here. This is the METI's strategy. Post 5G, beyond 5G projects. Then part of this beyond 5G project on your left-hand side, this is the development of the process, beyond 2 nanometer process. Beyond 5G, 6G telecommunication, then we need more efficient semiconductors. Then even more high complex, high density semiconductor, beyond 2 nanometer process, 1 nanometer, even more, such a process development in the scope. Then to achieve this, actually in Rapidus, they created new technology center, which is called Leading Edge Semiconductor Technology Center, LSTC. Actually, this is LSTC, but this is the actually Rapidus R&D center. Then they received huge budget for this beyond 2 nanometer process. Then new building coming up. Then R&D manufacturing. This is the background. Then you can see so many different names, but Japanese tech research institute and Tokyo University, Tohoku University, well-known older universities, and Applied Materials Japan, Kioxia, Samco. Yeah, and of course, you can see the small CA Leti from France and IMEC from Belgium. Those research institutes from Europe are part of this project. Right-hand side, this is the also next things, AI. We achieved 2 nanometer process on this project. Then right-hand side is in how we use that 2 nanometer process semiconductor. This is the national project of Edge AI accelerator development with the 2 nanometer process. Why we need this? Because Japanese government look at the use case in the Japanese society. For example, multimodal object detection, like different sensors combination, then do the annotation of the those object detection, and also noise reduction process, then such a huge data processing, and also data inference technologies, man-machine interface in the automotive, And of course, in the smart manufacturing, in the robot, and those things. And of course, in Japan is really aging society. Then lots of elderly people staying in house. Then they need a support. Then Japanese government really thinking about the robot will be the help. That is why such an AI implemented robot will be implemented into the ordinary family to take care of the elderly people. They have such a vision. Then to support that vision, we need a processor, AI. Then they are looking at the RISC-V ecosystem, CPU chip, open source software, and 2-nanometer device process, then edge AI. That's the background why we need Rapidus factory. Then Rapidus, they got the partnership with Tenstrand, Canadian company. Tenstrand is the, of course, in AI field, NVIDIA is a big name. But second, I think Tenstrand is really getting popular. Originally, they are from Silicon Valley, Canada. They have an operation in the States. Then they have RISC-V based chiplet technology for the AI. Then Rapidus, they got the IP of Tenstrand. That means Rapidus, they can design, and also they can design the manufacturing of the AI inference accelerator with the 2-nanometer process. And also, Tenstrand, they really wanted to have the manufacturing capability. Then point is here, shorter cycle time. These days, AI, of course, really rapid growth. Then research and development situation is really changing day by day. New findings, new research. Oh, okay, this is a really new way to do it, or technology is not really established yet. That is why AI chip got to be a smaller size manufacturing volume, but so many different varieties. Then different versions are coming up so quickly. That means really need a shorter cycle time on the AI semiconductors. That is why Tenstrand looked for the shorter cycle time, innovative manufacturing way. Then this got to be this partnership. Conventional semiconductor process. I think today's participants from the industry. So yeah, maybe most of you knows these things. Yeah, typically 25 or 50 wafers in one lot in container. Actually, this guy is holding one lot like this. Then this lot from the equipment. Then this one will be processed as a one batch, one lot. Then this is the conventional. Actually, most of the factories are like this operation. This is the best way and the most efficient way of the manufacturing for large scale mass production things. For example, Intel, CPU, billion of those to be delivered all over the world. Yes, this is the best way, batch manufacturing. But this process will got the process idle time. For example, this machine, yeah, actually this is the cleaning process or etching process. Then one lot placed in the machine, then process time, maybe 10 hours, 15 hours, depending on, maybe 2 hours, depending on the process. Then, okay, this lot finished, then next one is coming in like this. That means we need temporary storage space in the process, and also those one lot, 25 wafers container, they got process idle time. That means per wafer, turnaround time or cycle time of the manufacturing is quite long. This is not really fitting for the purpose of the AI chips. That is why Rapidus, their 2-nanometer process factory in Chitose, they will employ single wafer processing. They don't use 25 pieces container. Actually, their target is no stock, no waiting space in production line. Then single wafer is from start to the end, all the way. Series of the production, single wafer going. That single wafer processing manufacturing, that is the design of this factory. They call it RUMS, Rapid and Unified Manufacturing Services. Yeah, so many these 4-letter things today. Yeah. This factory design is really fitting for the AI chip need, like small quantity, high variety manufacturing, AI chip version A, B, C, D, E, really quick updating. Yes, you can do that. And significantly shorter cycle time. They say 40, 60% shorter. And also, depend on the lot, then cycle time is really different on the conventional way, but maybe 30% less cycle time variance depends on the different product or different manufacturing. And really, as everyone thinking about the 2-nanometer process, how high manufacturing yield can be achieved. It's really challenging. Maybe production yield could be quite low. But this is the reason why they will do the single wafer processing. Because in single wafer processing, on each process, they can monitor, they can get lots of data from manufacturing. Actually, 25 container, then 25 wafers, then getting the data on each wafer is kind of a challenging thing. But single wafer processing, you can get enough amount of data from wafer on each process that will directly connect to the continuous improvement of the process. That is the they really want to keep the manufacturing yield high. That is their target. Then now Rapidus is really closely working with the manufacturing equipment companies how to realize this single wafer processing all the way from start to the end. Japanese government promotes Rapidus to the global market. This is the picture from the METI. Actually, last year, November, American semiconductor companies visited Japan, then had a meeting with the Japanese government and also Rapidus. You can see the face of the CEOs like, NVIDIA, AMD, and also different companies. Then AMD, Apple, NVIDIA, these big names, they were invited by the minister. Then actually this is the top sales of the Rapidus 2-nanometer process. Yes, we will achieve 2-nanometer AI chip, dedicated, brand new process, factory available in Hokkaido. You should manufacture those chips in Hokkaido. This is the top sales. So move to the next topic, Ouranos. I'm not talking about Greek myth things, but Ouranos-Ökosystem. This new challenge is happening in Japan. Ouranos is the big data platform like a Gaia-X in Europe. But the slightly different part is the Ouranos-Ökosystem is directly connected to the Japanese government vision, Society 5.0. Industry 4.0, then beyond that, lots of 5.0 concept is coming up from different countries. Then Japan, we are working on Society 5.0 concept. That is integrating cyberspace, data, things, and physical space where we live here. Those two things are closely connected. Digital twins, all the sensors, those virtual world and real world will be connected. Then that data platform will be a Ouranos. Then METI is really pushing these things together with the our industry organization, NATO, and also data promotion agency or this organization. This is the government project, national project. Then private companies, big companies are getting on board. Then covering area, it's like mobility or sustainability, recycle, industry, supply chain, construction, the geography, 3D maps, those things. This is quite similar to the Gaia-X in Europe. Actually, Gaia-X really big data platform, then different industry, they are working on different X, right? Energy, Omega X, or yeah, like yeah, lots of different things. Then already working really up running is in Catena-X for the automotive industry, and also agriculture data hub. These two are the lighthouse projects. Then Catena-X is really working on the automotive industry, thanks to the electric vehicle battery recycling, battery passport scheme. Then Catena-X is really up running now. Japanese Ouranos-Ökosystem. Two major points we are focusing. First thing is, four-dimensional space, time, information, infrastructure. Sounds like a really the science fiction things, but actually this is the issues like aging society. Then how we secure our transportation of the goods, how we achieve autonomous vehicle driving, how we keep up our manufacturing, less number of the working force, or those things. Then to achieve this, we need the data, we need a platform. Of course, 3D, XYZ plus extra dimension, that's a time. That is why four-dimensional information infrastructure. Second thing, supply chain data collaboration platform. This is quite similar to the Gaia-X, Catena-X in Europe. Actually, battery recycling and also product passport. Actually, European government is really pushing product passport, all the finished goods, materials, all the way supply chain, then traceability. That's such a big platform. Actually, Japanese government is trying to do the quite similar things here, local market in Japan. Then this 4D space things and also supply chain data, these two data platform will up running this fiscal year and next fiscal year. This is a plan. Then big Japanese companies like Mitsubishi, Toshiba, or NTT, or those people are getting on board, and automotive industries are getting on board, then really up running. This is also quite similar to the Gaia-X, Catena-X. I think Catena-X is promoted by the Bosch or Siemens and those big German automotive companies. They are getting on board, then really pushing. Yeah, actually similar things are happening in Japanese market. This is the one of the example projects of the 4D space, time, information, infrastructure, like a scientific fiction things. 4D digital infrastructure, like a really high precise 3D geometry data, much better than GPS, and also lots of sensing data from the field, then combined together, then for the digital space information available, then this information will be available for the industries. Like, for example, traffic, how to make our traffic smooth things. This is one thing. And construction, flying drones, how to secure the flying path or in a booking system of the airspace, or social infrastructures, and also environment in the city. And yeah, big topic in Japan. We have earthquake, we have tsunami, typhoon is coming in, such a national disaster thing. Then how to prevent and how to recover after happening. Then for such a topic, this 4D space-time information infrastructure will be used. Then NTT or the different big companies are actually running the project on this scheme. Second topic, supply chain. This is quite similar things as the Catena-X in Europe, automotive. Actually, Japan, we start in Europe. You started already digital product passport things from the EU government, and the battery passport, recycling the EV batteries. Similar scheme we started in Japan, automotive and battery traceability center. Then, of course, this database is connected to the Catena-X in Europe, actually exchanging the data, traceability data connected, then exporting Japanese car to the EU, but we have a database here, then just the database, interactively connected communication, then necessary information will be shared, delivered. Such a data platform things. In Europe, Catena-X, Gaia-X is running. In Japan, Ouranos-Ökosystem are running. These two are collaborative, working like this. Actually, Japan, we have a ministry called the Digital Agency. Then high-level discussion is always happening. Japan EU digital partnership. This partnership discussion is really ongoing. That means Gaia-X in Europe and Ouranos in Japan. Yeah, like a Greek mice collaborate together. Gaia on the ground, Earth, then Ouranos, sky, heaven, yes, collaborate together things. That's the data platform, new things. So maybe time is running. Last, we talk about the smart manufacturing trend in Japan. You know the word Kaizen. Kaizen is the Japanese. Actually, Toyota created this scheme, philosophy of quality. Kaizen means continuous improvement. Make it better. Then Japanese manufacturing company really characteristic things is Kaizen is always bottom-up approach. Small working group in the production line, they have a big power. They have a big mouth, big words. Hey, we need this improvement. This will be the really good idea to make our production better. Then such a word is going up. Then such a Kaizen activity is happening. That this is then how we created then high quality manufacturing in Japan. Then digital transformation, make it digital manufacturing. We need approach of the bottom up. Of course, SAP or such a digital systems, digital strategy things coming from top down, but in Japan, we have a culture like a Kaizen bottom up. Then how we meet together, top down approach and bottom up. This is the really challenging things of the digital transformation of the production line in Japan. Asahi Kasei, they are one of the biggest chemical company. They have factories in Japan in several places. They have 40,000 employees all over the world. Then so many manufacturing workers, so many Kaizen small groups in the production line. They have to be digitalized. Then where this company focusing on, of course, they do material informatics or in a new approach, digital platform things, but their management got realized, yes, our people need to be digitalized. Then they have a special program. All of the people, 40,000 employees, they should be digitalized. Then huge amount of educations and programs and new software platforms, which is accessible for everyone, such activities they are working on. Second thing is, of course, less number of workforce, then aging society, then people need to work together with robot in the field. But that robot needs to be programmed with the skilled people. But that is then really not really practical things, because always specialist is necessary. But in the reality, in the production line, guy working in the next, hey, please do this, do that. No, you should not do this. Oh, today your work is like this, like that. Please be careful on these things. Such verbal communication. Then your companion or co-worker robot should behave like a co-working person. Then such a project, Denso is working on. Denso is one of the biggest co-working type of robot manufacturing company in Japan. Then generative AI, verbal communication, communication, then you can work together. Such a project they are working on. Conclusion, semiconductor things. Japanese government put lots of subsidies. Then TSMC is coming to Kyushu, Silicon Island, really back. New factory Rapidos, Hokkaido, 2-nanometer process, targeting AI chip market, then single wafer processing. Let's see if really it's up running. Then second topic, we talk about Ouranos-Ökosystem. Oh, sorry, I made a typo. Ouranos and not air. Ouranos-Ökosystem. This is the based on the targeting society 5.0 Japanese strategy. Then two major points: 4D space-time information infrastructure and supply chain data, like Gaia-X battery passport. Then on the context of the battery passport, supply chain, Gaia-X and Ouranos-Ökosystem are connected well, like Greek mice, Gaia, Uranus. Then smart manufacturing. We have a Kaizen mindset, bottom-up organization and actually manufacturing. Then digital transformation. We are seeking the possibility how we bottom-up and top-down digital transformation, how we meet together. Such a project is ongoing. Yes, that's the end. I think, we have 4 or 5 minutes, maybe a quick Q&A session. We can dive in, right, Arnold?
Yes, indeed. So thank you very much, Andy. I want to just then bring up one last topic and share the screen here again. So this is what we, of course, Semicon Japan is happening this year again. Usually in December, 11th to 13th of December this year. And there is a brand new institution funded by the EU. It's called EU Business Hub. And it happens that they just yesterday published their first trade mission, where they are supporting some 50 European companies to come to the trade mission Semicon to Japan, will be in the Semicon area. So we are evaluating whether we do an individual Austrian trade mission, a Wirtschaftsmission to Japan for the Semicon, or we will recommend anyone interested to participate in the EU mission and support, of course, the Austrian companies as best as we can. And we, that means, of course, me, but also most importantly, Andy, who will be our key account manager for the months to be, and of course, support any Austrian company that participates in either our trade mission or the trade mission by the EU Commission. So then this having said, thank you very much for participating in the webinar today. We will send out the information containing the slides that Andy showed today for download for any of the participants. And then, of course, also send more information about the EU Business Hub mission to Japan or our own trade mission. And I hope to see you either in Japan or in Austria anytime soon. Please also think next week in Austria, we have the Exporters Day in Vienna. So there is all the trade delegates, all the head of our missions, the Wirtschaftsdelegierten from Asia are all in Vienna. So if you have questions for the market in Japan, Taiwan, China, any other country, please visit us at the Export Tag in Vienna. It's not too late to sign up. And later this year, this is still far away, December 5, there will be an Asia Day in the Federal Economic Chamber, the Wirtschaftskammer, in Vienna. So that also be a lot of Asian topics and of course also high tech and innovation. Finally, really final, for next year, Osaka Expo 2025. There is the Austrian pavilion. It's in the making. They're looking into how to fill it with good content. There is right now a call open on bringing innovative ideas, technologies, input, content input for the Austrian pavilion into the discussion. I will send you the link how to provide your input via the feedback email. Please participate. I think we have a lot to show to the world. And as you know, this is not only Japan audience, but also the audience from all over the world that will come to Japan for the expo. So thank you again for participating today. Have a nice day from Japan, Tokyo.